Okay, first, maybe I should start our introduction from here. So, good afternoon, everyone from India. I'm Sebastian Lai of the Taiwan Hydrogen and Fuel Cell Partnership. So, I have to say, we have to express our thanks to the GS2 India for organizing a previous event. So, I believe the last time that was we have invited several key players in India upon hydrogen and ammonia business to introduce what's happening now in India. So I believe now it's our turn to share what's going on now back in Taiwan. So today we have invited, including myself, four speakers, and one is the THFCP. We will be sharing the whole big picture of what's the industrial chain, what is the ecosystem like in Taiwan. Then later on, we'll be having experts from the ITRI. They will be sharing their experience in developing the fuel cell powered UAV. And later on, we'll be inviting the speaker from ITRI Taiwan to share their planning of using ammonia ammonia utilization in Taiwan market. And final will be another speaker, the vice president of Blade Hydrogen, to share about their utilization of fuel cell. Okay, so for now, I'll be sharing my slide with you. Allow me to do some introduction about today's content. We'll be introducing about ourselves, then the industrial chain in Taiwan, then the policy regulations and the utilization of hydrogen and ammonia in Taiwan. And the last will be what will be happening in this business in the future in Taiwan. Okay, first of all, we are the Taiwan Institute of Economic Research, and the Taiwan Hydrogen and Fuel Cell Partnership is operated by the TIER. We are a private think tank founded in 1976, one of the most earliest private think tank in Taiwan. And so far, we got not just the THFCP, we got more than 20 different industrial associations operated by TIER, which include like smart grids, and the CCUS and semiconductor high power device applications, and the aerospace additive manufacturing industry, etc. So I'll be skipping all these details. So some information about the Taiwan Hydrogen and Fuel Cell Partnership. We have founded about 20 years ago. So back then, our vice president has realized that hydrogen is a very important solution for clean energy. So back then we have founded this organization. And the organization, so far we got over 90 member companies. Most of them are private sector and some of them are research institutes. And based on what they are specialized in, we have categorized them into different groups. For example, like stationary, transportation, and portable fuel cell, and the key component for fuel cell and energy saving application, etc. Okay, so let's have a quick review on the entire industrial chain in Taiwan. So this is what it looks like when we're talking about hydrogen value chain, including different types of different ways of producing hydrogen and its treatments and its transportation and also its utilization. You can either use it for vehicle, can use it for industrial use and heat and power and industrial use, etc. So when we're looking at the hydrogen production, I have to say that in the past, most of our companies, they are focused on the key components for fuel cell or fuel cell production itself. But now, later on, more and more companies have devoted their technology into electrolyzer. For example, like the U-Hydrogen, so far they have developed their own self-developed PEM electrolyzer, and they have a demonstration site in Nantou, and this site is combining with the fishing farm, so that the hydrogen electrolyzer can be sold to the end user for industrial use, and the oxygen will be used in the fishing farm for the fishing industry. And another company is called the Pilot Energy. They have also developed their own alkaline electrolyzer, and they also have demonstration sites in Yilan, the northeast coast of Taiwan. And they're also seeking chances to sell these clean hydrogen to industrial users. And when we're talking about the key component supplier, I believe that you all know about Bloom Energy. So in the past, four of our key component supplier have become four of our company have become the key component supplier for Bloom Energy, including Cowrie and ProRite, Akbel for electrical management system, and Plus Metal. All of these combined, they have account for about 30 to 40% of Bloom Energy's SOFC's cost. And not just these four companies, there are also many other players, including like bipolar plates, catalyst, reformer, MEA, and carbon paper, IEM, stack, radiator. I'm not listing all of the company, but all of these, we just want to show that there are many players are in this business in Taiwan and are capable of providing these key components. And we're not just the key component supplier, we can also be a consumer of fuel cell. I believe that you all know that Taiwan is a country that's very famous for semiconductor and manufacturing. But however, when the net zero trend comes, these manufacturers, they need to reduce their scope 2 emission. That's why that more and more companies, they're willing to implement fuel cell as their backup power or baseload power. For example, one of the ICT firm called Unimicron, they have spent 4.041 billion NT dollar to build up to 10 megawatts of Bloom Energy's SFC. Use it as baseload power spread around their factory. And also another company called ProRite, which is also the supplier of Bloom Energy. They have also about to purchase 1.2 megawatts of SOFC, also use it as their baseload power. We're not just the consumer, we can also be the producer of electrolyzer or fuel cell. For example, like Delta, they are a world-known energy solution company. They also have a branch in India. And now, back in 2024, January, they have signed a contract with the British Cirrus Power to acquire their technology on SOFC and electrolyzers. And so far, their production line is about to ready by this year, and believe we'll able to produce up to 10 megawatts of SOFC and 30 megawatts of SOEC biannual. And these are some products that's been developed in Taiwan by Taiwan local company. For example, like CHEM, Top Plus Energy, M-Field, Cowrie, and High Power. Some of them are using methanol water and some of them are using hydrogen. Just want to show that these Taiwanese companies, although they might not be a super large scale, but they are very good in R&D and the product development. So with cooperation with these companies, they have developed their product in the past. So back in 2015 to 2020, we have the THFCP. We have been working closely with the government, with the National Communication Council and the Energy Administration to help them build up. I think it's so far over totally 60 demonstration projects across Taiwan. All of these are in a rather small scale, for example, like 5 kilowatts, 20-something kilowatts. And all of these fuel cells are used as backup power for these public-owned housing or community centers, or some of them are located in remote areas. So they in these cases, the fuel cell is used as backup power for the cell phone bases in the remote area. Because I am not sure, you might know that Taiwan is a country that we're often been disturbed by either earthquake or typhoon, hurricanes. So once these natural disasters happen, it's very important for these remote area still have the backup power to reach out for help. Okay, and due to regulations, restrictions, so far we don't see so much hydrogen vehicles on the road. However, in the past, many of our company have also worked with the Ministry of Economic Affairs. Some of those are pilot projects. So in the past, we have developed go-karts and drones and boats and forklifts and parked car and scooter and passenger car and bus are still ongoing its development. And so far, we have built our first HRS in Kaohsiung, the west southern part of Taiwan, working by it's built by the China Petroleum Company and Linde. And this is a big picture of the entire supply chain, or I think we can call it an ecosystem about hydrogen and fuel cell industry in Taiwan. So on the left-hand side, you can see about fuel cell from a raw material and stack and system application. We got a lot of companies that are capable of providing these key components or system. As for the peripheral product, when we're talking about alloy tank, methanol supply, and some purification system and methane supply and some on-site hydrogen production. We got a lot of company there all capable of being in this business. And feel free to make a screenshot or take a photo of this QR code. You can link directly to our official website so you can learn more about our companies. Okay, so I know that in the previous meeting with GS2 India, that India is with a very abundance of renewable energies and having a large focus on the production of green hydrogen or green ammonia. So later on, I'll be introducing what's happening now in the hydrogen and ammonia policy regulation and what will be happening in the future, perhaps in the business parts. Okay, so if we take a look back in what's happening in Taiwan, so back in 2022, we have proposed our net zero emission plan, and based on that net zero emission plan, the previous governments, they have come up with the 12 key strategy, and hydrogen is one of them. Back in 2022, so back then, hydrogen has been focused on its utilization and its infrastructure and its local production. And now later on, the present governments they have issued last year January they have issued another revised policy on hydrogen and ammonia. It's called Hydrogen and Ammonia Supply Chain National Flagship Plan. It's jointly supported by the Ministry of Economic Affairs and National Development Council and the Ministry of Environment. So these are the policy part. I'll be moving on to more detailed information about this policy. And if we take a look at what's happening about our regulations. So the Energy Administration Act so far has included hydrogen as one of the energy resource, and also the regulation for hydrogen fuel HRS has also been implemented back in 2023. And so far, the Ministry of Transportation and Communication, they are providing a subsidy project for hydrogen bus, these numbers have been updated. So far, they are providing up to 20 million NT dollar per FCEV bus, and expected to bring it up to 60 FCEV bus by 2035. And by 20 million NT dollar per each bus, this fund is basically can cover up to 60 or even 70% of the cost for the transportation service provider to purchase the bus. It's a very great incentive. And also the National Fire Agency, they have included the hydrogen and on-site hydrogen production in their safe guidance. So about the National Flagship Project. And so far, they have allocated more than 12 billion NT dollar upon this flagship project, and it's divided into different type of goals, including energy sector, industrial sector, and the transportation sector. But if you take a closer look on the energy sector and industrial sector, both of these are basically have a large focus on using hydrogen or ammonia as a low carbon fuel, or we call it alternative fuels. So if these goals have all been successfully conducted, we're expected to have accumulative up to 2.688 million tons of carbon emission reduction by 2035. And this is the carbon emission reduction by year. And if we take a look on what's happening, some more details on what's happening upon the regulation. So there are both pressure and incentives for companies to use more hydrogen or more fuel cell. The pressure side, if we take a look at the pressure side, it's called the compulsory user of renewable energy. So based on our Renewable Energy Development Act, the large scale power user, by definition, we call it with power user, their contract, it's over 5,000 kilowatts. They will be defined as these compulsory user of renewable energy. So all of these compulsory users will require to provide to use 10% of renewable electricity biannual. So this provides an incentive for them to use either its green hydrogen or green ammonia or implementing more fuel cell. And also, the Energy Administration is providing a subsidy subsidy demonstration program for the implementation of fuel cells. So it provides 70,000 NT dollar per kilowatt. And if ideally it can cover up to 50% of the CAPEX and OPEX for implementing the fuel cell. And so far, we got 49 fuel cell demonstration sites spread around Taiwan and with over 5,000 kilowatts capacity have installed. And not just these regulation, let's say incentives or pressure, but also some actual incidents that could incentivize the industrial user to implement more fuel cell or using more other solutions for energy solution that will be using hydrogen or ammonia. So everything started back in the 2017. The Electricity Act, they have mandated to commission all the nuclear plant by 2025, and that actually happens. And now we can see that once, so far Taiwan is called the no nuclear homelands. The policy is called that way. But so far, if we have removed all the nuclear power, the reliance on coal and natural gas and the fossil fuel has the percentage of using all these fossil fuel has bring up to I think it's over 90% on the dates of power on the date of 18th of May in 2025, the day that we shut down our last nuclear power plants. And as we all know, that renewable power is very fluctuates, and Taiwan is a small country. We have a very limited land and economic exclusive zones. So yet we are still building more and more solar PV and also more and more wind turbine, but still there's a limit. So we can't be always relying on these fossil fuel. And due to this shifting of our energy policy, many power incidents in the past have happened. And you might know that Taiwan is a country famous for semiconductor, and these semiconductor, their production process, it can be stopped. These factory, their power doesn't allow to be shut down. So these incident has also become an incentive, and it's like a crisis management for these companies. So they're also seeking for some on-site electricity generation for these companies themselves. For example, like TSMC and other famous semiconductor producers. So now, as we can see, just as I introduced previously, we have helped the Ministry of Energy Administration and the National Communication Council build up many backup power in community and remote area, so it can be used in the residential and commercial sector. And fuel cell can also be used in the industrial sector as baseload power, for example, like in the case of Unimicron, 10 megawatt SOFC, and co-rides up to 1.2 megawatt SOFC. And also the famous TSMC, they also now start trying to use a recycled hydrogen from their process, from their EUV process, and to be put it into the PMFC to generate electricity in. And as for the transportation sector, so far we have one company, they are producing their self-developed hydrogen FCEV bus. And the Type R company, they're the largest, and I think it's the only power dispenser and a major power generator, a major electricity producer in Taiwan. And so far, they have signed contract with Siemens and ITRI, later on our speaker, and also the Mitsubishi upon the ammonia and coal co-firing and the hydrogen and gas co-firing technology. So this is what we can see now happening in Taiwan. And what about in the future? So in the future, not just some public sector like the Central Weather Administration and the Internet Center and the National Science and Technology Council, not just public sector, but many other private sector, including like Foxconn, Enlight, Foxlink, and also AMD and NVIDIA. They have all claimed to be building more and more AI data center in Taiwan. So again, if these AI data center, if they are also facing these kind of energy, electricity incidents in the future, they would definitely seeking for some other solutions to secure their energy supply. So now the hydrogen has become a topic that's been more often being discussed in Taiwan upon these issues. And the last part of my presentation will be the design of hydrogen and ammonia campus in Taiwan. So I'll move it fast. So according to a very expertise research institute, the ITRI, our later speaker, and according to the estimation that the hydrogen and ammonia demand by 2050 will be up to the demand for hydrogen will be up to 4.06 million tons, and demand for ammonia will be up to 3.15 million tons. And among these demands, that's all of these ammonia are expected to be all imported, and for the hydrogen, up to 2.35 million tons of hydrogen will be imported. So, which makes Taiwan a very large and a potential importer of either its ammonia or hydrogen, either it's in liquefied or gasified form. And if we take a look on some potential off-taker, or I think we can call them the key player in the future, that the Taiwan Fertilizer, they're still now an state-owned enterprise, and with a very long developed history. They have a very good expertise in the treatment of ammonia and the production of fertilizer. And now in recent year, they have realized their role can not just be in producing fertilizer for agricultural use. They can also be an importer, importing ammonia as the energy provider. So in 2023, they have imported the first bulk of blue ammonia from Saudi Arabia. And so far, they have 2 liquefied ammonia terminal and storage tank in the central part of Taiwan. That's called the Taichung Seaport. And in the future, they're expecting to build up to 80,000 tons of the storage tank, the storage capacity. So makes the Taiwan Fertilizer a very great potential cooperation company for India. And not just the Taiwan Fertilizer. If we take a look on the end user, the China Steel Making Company, they're one of the earliest steel making company that claim they will start using hydrogen and ammonia for their steel making process as an alternative fuel. And also the CPDC and LCY Chemical. Both of these companies, they can also use ammonia for their chemical treatment and refinery process. And interesting thing is that both CPDC and LCY Chemical, they're not just the user itself. They're also capable of doing the ammonia transportation and imports. So not just Taiwan Fertilizer, LCY, and CPDC can also be your potential partners in the future. As for the Thai Power Company, not to mention, they are expected to be the largest demand. They're expecting to bring the largest demand for ammonia in the future, which will be using ammonia in the coal-fired power plants. In the last 2 slides, I'll be sharing some information about the we call it campus in Taiwan. And there are many words in this slide, but I won't go into detail, but to give you a brief introduction of the idea. So far we are working closely with the government to help them design the two, we call it hydrogen and ammonia campus. By campus, we mean that it include both the unloading terminal and also the utilization scene in these two places. So one is in the Taichung port, is in the central west part of Taiwan, and the other one is in Kaohsiung, the southern western part of Taiwan, both of these ports. So let's take a look first at Taichung. So Taichung so far they've got enough vacancy to build more terminal in the future, and China Petroleum Company, they also have a tank for chemical for oil and chemicals in Taichung. And the most important thing is that there is a coal-fired power plant which is only 500. I think it's less than 1 kilometers away from this expected site for the terminal. So if in the future we are able to build the if we're able to build the terminal here, ammonia terminal here in the future, the ammonia can send directly by pipeline to the coal-fired power plant, which is an ideal demonstration. And it's not just by demonstration, we doesn't mean that it's small scale. It's actually could bring a large demand in the future. And another case will be the Kaohsiung port. So Kaohsiung is the largest international cargo seaport for Taiwan. And so far, Kaohsiung, they got CPTC. They're planning to build 2 liquefied ammonia storage tank in the future. And despite that Kaohsiung, they don't have a coal-fired power plant very nearby, but they have two great potential. So one is that Kaohsiung, they have a very large industrial cluster, manufacturing cluster, very close to the seaport. So the ammonia can be used for can be unloaded and being transported directly to the industrial park and for the industrial use as alternative fuel. Another thing is that the harbor administration in Taiwan, they're now starting to plan to build the alternative fuel bunkering service in Kaohsiung port to attract more sea cargo ships to come to Kaohsiung to do the refilling. And now, so far, they're thinking about the methane and also the biodiesels, but now the ammonia is also on our table now. So in the future, the bunkering service for ship and the supply for alternative fuels for industrial use could be the two, let's say, very key utilization of ammonia in the future. So these two sites, the design of two sites, despite they are not yet built, however, they have demonstrated the great potential of ammonia demand in Taiwan in the future. Okay. Oh, sorry. I think I'm a few minutes later than my plan. Sorry. And that'll be all for you today. Thank you. Okay. So allow us to invite our second speaker today will be the Dr. Martin Tsai. He's a senior researcher at the ITRI, the Material and Chemical Research Laboratory. So Dr. Tsai, the floor is yours.蔡研究员那个
Can you hear me?
Yes, yes, thank you.
Okay. Wait for a moment. I open my slide. Okay. Okay. Can you see my slide?
Yeah, visible.
Okay. Good afternoon, every audience from Taiwan and India. I'm Martin. I'm serving at the Material and Chemicals Research Laboratory in ITRI. And this topic will focus on the fuel cell power drum development. And ITRI is located in the north of the Taiwan and founded in 1973. And ITRI has played a vital role in the transformation of Taiwan's industry from the labor-intensive to innovation-driven. And now in ITRI has total step around more than 6,000 people, and PhD account for 20% in ITRI, and many research area or research topic in ITRI have been done and has been proceed. The green energy and environment is one of the research topic in ITRI, and today I will share introduction our division technology development and our our achievement in the hydrogen energy technology. So what we focus on, we divide into two parts. One part is the hydrogen production, and the other part is the hydrogen application. And in our division, we also develop the different kind of hydrogen production technique. One is the water electrolysis, and the other one we also use the electrochemical hydrogen purification technology to purify the waste hydrogen and can reduce the carbon emission. And the other one in the hydrogen production, we develop different kind of fuel cell power sources to apply in different application. So can use in the UAV or the truck or forklift and bus. And in the technology development, two main category development in ITRI. One is the air-cooled fuel cell power system, and the other one is the liquid-cooled fuel cell power system. In these two different type of fuel cell system, we choose the different advantage to apply in the different application, such as the direct air-cooled fuel cell, because we can remove all of the unnecessary BOP component, and we can reduce the system weight and to increase the power density in this type of fuel cell system. So it's suitable for the UAV application or suitable for the mobile power bank to extend the power generation. And the other one, if you want to get the higher power, so we can develop the liquid cool fuel system. But this system is complicated composition because we use many control to control the air supply or to control the humidity and hydrogen supply in the system to get the stable system and generate the stable power, and is suitable for the bus application or truck or stationary power application like that. So we in our division we develop different kind of spec for different application, such the air cooler stack, and then we can assemble the stack to obtain to integrate the system to generate power to supply power to the drone to extend the flight longer flight time. And the other one, we also developed the liquid cool, stack can embed into the power system to generate the power to supply to the truck and bus power generators. So in this topic, we will focus on the drone application. Two critical parameters are concerned in the drone development. One is the hover power, and the other one is the cruise time. And this decide the drone performance. So usually in the although the lithium battery has the higher power, but the energy is too low, so it cannot make the longer flight. So from this figure, we can see the hydrogen has the better energy density than the lithium battery. So hydrogen maybe is a better candidate for the longer power generator to provide the longer power to the drone application. So we can see in this figure, the fuel cell can provide higher energy density, more than 500 kilowatt per kilogram, and then can get the longer flight time. So how can we obtain the better drone design? Three important component we need to consider. One is we should simplify the fuel cell component. The second one, we can get the high power and lightweight fuel cell stack, and the other one, we have the high efficiency hybrid control technology. And the one in the traditional fuel cell system is complex, so we should simplify the fuel cell so we can remove the unnecessary component like such as the humidifier or water cooling system like that. And we use the humidified MBA, and we can use we can use in the low humidity environment to get a high power. And we also can use the lightweight and high pressure hydrogen cylinder to increase the hydrogen energy, can provide a higher energy density. So in the second one, we developed the high weight and strong mechanical strength UAV body design to get a higher strength body, UAV body, and can reduce the body weight. And we also in this research topic, we also get the light from the light payload and get a high efficiency motor in the voltage around the 50 to 60 volt, and then we we go to the heavy payload to get the high efficiency motor in the range of the 100 volt. So we can get the lightweight drone body and get the higher strength mechanical design. And the other one would get a high performance fuel cell stack due to we also get use the metallic bipolar plate, and we can assemble the high performance cool MEA to get the high performance stack. And also we assemble the lightweight BOP and optimize the power control. So in the fuel cell stack development, we can get a higher power density in our development. And then in the fuel cell hybrid power system for drone application, because in the different scenario, we can if the fuel cell power higher than load need, so maybe the fuel cell can get enough power to charge the battery, and in the different situation we can adjust the power output to optimize the fuel cell, to optimize the operation efficiency. So in our system, we developed the high efficiency hybrid power technique to get the nearby the 100 efficiency to get the higher to extend the flight time. So in the fuel cell hybrid power helicopter, in this one, we combine with the higher power density stack and use the multi-stack control and the high efficiency hybrid power design. We can develop the longer endurance fuel cell helicopter. And this drone can has been evaluated for many flight tests. The accumulation flight distance is over 100 kilometers. So because the weight of the drone is higher than 25 kilograms, so we also have passed the spatial inspection certificate of the Civil Aviation Administration. So this drone can perform the different kind of mission and to do some application. So we do the test from since 2020 separate us to verify the fuel cell power drone stability and to test the flight to understand the longer flight time. And then we test the different environment to deliver the material and also get the better performance to do the test. So in different tests, we complete the mountain and cross-it mission, and then we use the anonymous flight GPS and emergency landing setting for a hydrogen drone, and we can monitor the flight route and ensure the safety of the drone. And in this case, hydrogen drone is easier and faster to feel the energy by the replacement of the hydrogen tank. So we also promote the fuel cell power drum in during these years, and also develop the high payload fuel cell tandem rotor UAV, and for the heavy carrier mission. And we also developed the high weight fuel cell helicopter. The maximum takeoff weight is 25, so it is unnecessary to pass the special inspection certification, so it can directly to perform the mission we want to do. So and now we also developed the high payload fuel cell tandem rotor UAV to solve the telecom networking area. So we can use this drone to apply in the expand the telecom communication network area. So since 2019, we got the funding from the government, and then we do many research work and complete the different kind of drone development, and apply the different apply the drone to different application. So this is the last slide. So let's me recap my presentation. The high performance stack and hybrid power control technique make the drone fly longer and have a heavy payload. And in our division, all of the hydrogen energy system have complete and applied in the practical usage, and understand the integration issue. So from the development achievement, in the near future, we are looking forward to have an opportunity for collaboration with all of you in the near future. Thank you for your attention.
Okay, thank you, Dr. Tsai. Thank you for your time and a very detailed sharing of your experience on developing the fuel cell powered UAV. So the next speaker for today, please allow us to invite Mr. Wen-Fu Wang to he's the sales manager of IHI Taiwan, and he'll be sharing the introduction of IHI ammonia value chain and the Taiwan market business. Okay, Mr. Wang, the floor is yours. Sorry. Yeah.
Yes, can you hear me?
Yeah, very clearly. Thank you.
Okay, and good afternoon, everyone. This is Wen-Fu from IHI Taiwan, and it's my pleasure to have this chance to share the IHI Group fuel ammonia value chains, and also the Taiwanese in the market in Taiwan for everyone. So let me start to introduce you about the IHI. Actually, IHI is a Japanese company, and we set up the Taiwan subsidiary from the 1950 something. Now it's around 60 years. And in the IHI Group history, we established in 1853. So far up to now is 170 something years, and there are around more than 28,000 employees in the world, and we have the 6 workshop and 21 business development bases in the world. And as for the IHI, I would like to share you more about IHI business group business. And the first one is about the resource, energy, and environment business area. In here, that our principal business is about the power system, carbon solution, and nuclear energy. In the power system, we have the LNG, we have the gas turbine and the diesel turbine. And as for the carbon solutions, we have the ABC. A is ammonia, B is a biomass, and C is the carbon capture and utilization to be applied by the methanation. And the last one is the nuclear energy. Then the second field, that is the social infrastructure business area. In here, we have the bridges and the water gates, the transportation system, and shield machines. Then the third field is about the industrial system and general purpose machinery business area. In here, we have the turbochargers, we have the parking system, we have the rotary machines. And then the last one is aero engine, space, and defenses business area. So in here, we have the aircraft engines, we have the rocket system and the space exploration, and we also have the defense equipment and systems. So above four areas that constitute that IHI group. And today, the ammonia value chain is mainly focusing is the field of the resource and energy business area. Okay. So why ammonia? So I just started the ammonia study from 2011, and from there that we pick up. There are several alternative fuels we can apply. For example, ammonia, liquid hydrogen, and MCH. And in here, we pick up ammonia due to some key factors. For example, the tank capacity ratio and the tank material, boiling point, and the storage system. In here, that from the tank capacity ratio and the boiling point and the storage period, among these, we evaluated that ammonia could be the most suitable to as the next generation for the decarbonization fuel. So in here that we have the clean ammonia production projects all over the world, and in India, we have several projects in the world, and one of the most aggressive projects in India, we work with the ACME, and ACME is also one of the partner in the green hydrogen in India, and we are discussing the offtake agreement, and everything is still under discussion investment. And we have the US, we have Australia, we have Oman, and in different countries we have our different business strategy, and is being discussed. Then it is about the IHI ammonia storage technology. So IHI has been selected for the feasibility study for the hydrogen supply infrastructure development project in the 3 locations. One is nearby at the Hokkaido area, that is Tomakomai project. Then another one is the Soma, and the next one is the Kansai area. Yeah, so IHI is doing the feasibility study for the storage technology in Japan. And here that we are start to tell you about IHS ammonia value chain. So why ammonia value chain? We can separate it into 3 phases. The first phase is production. Second phase, the storage and the transportation. And the third phase is utilization. As you may know, that IHI is the famous heavy industry equipment supplier, and we have our own technology for the gas turbines, for the boilers. And in here, that we start to modify our burner in the boilers, and then we made some tests and realized that the ammonia can be the fuel for the next generation. So we finished the utilization development, then the production, and then the usage of the ammonia comes, then we need some production. So in the production energy that we have the technology to do the ammonia synthesis from the hydrogen to the green ammonia. And then we also can supply the green ammonia to the world. And when the supplier make the ammonia, then they need the tank. And then if the importer they need to use the ammonia, they also need a tank. Yeah, so IHI, we have our technology to make the ammonia tank, and in between we need a ship, we need a transportation. So IHI is also doing the engine modification from the oil engine to ammonia engine. Yeah, so in here you can see this is the IHS ammonia value chain as of today, and we were the heavy equipment heavy industry equipment supplier, but now we are not just the equipment supplier, but we are also the green fuel supplier, green fuel of the ammonia. And here is the IHI's ammonia utilization product lineup, and you can see we have in the different field. So in here, this is for the power. We have in the maritime, we have in the industry. So in the power field that you can see here is the boiler. So please pay attention. In the boiler, only the boiler, we use ammonia and coal firing. Co-firing. In below, these are old engine and the gas turbine. Those are all 100% ammonia. So let me introduce you about the boiler first. In here, we developed the ammonia combustion technology in our boiler, and we have done the 20% ammonia combustion in the GHIWS Hekina thermal power plant in 2024 from April to June, and the result was very good, and everyone was satisfied for that. And then we are developing the large gas turbine. We signed the MOU with GE, and then we are trying to apply the IHI 100% ammonia combustion technology in GE's gas turbine. So we are targeting by 2030 to finish the development. And then we have the maritime. So we are developing the reciprocating engine for the vessel use. And then this demonstration started in 2024 July, and the ship to be completed by this year, November. And when we have the ammonia engine for the vessel use, we can also use that as the land use. So in the land use, we have the ammonia and diesel dual fuel engine in next year, 2027, and we will have 100% ammonia combustion engine for land use in 2028. The next is about the industry use. So for the small gas turbine, this one is the world's first ammonia combusted gas turbine to achieve the carbon dioxide free power generation. And the durability test was conducted in May 2024 to 2025, and we plan to commercialize in this year. And this one is not only just the first in the world, but also the ammonia fuel can be the liquid ammonia, not gas ammonia. And the last one is about the furnace application. Then this one is under developing. In here that I would like to introduce about IHS decarbonization roadmap in the power sector. And we have the GT. Okay, we have the 2 megawatts to complete in 2026. We will have 400 megawatts to be completed by 2030. And we have the engine, and that would be the marine use and the land use, and it would be commercialized in 2027 and 2028 respectively. And then the boiler that we have done the 20% ammonia and coal co-firing in 2024. And then we plan to do the ammonia and coal co-firing more than 50% by 2028. Yeah, so in this roadmap, you can see we are now in 2026 here, and then to the 2050 in the future. And you can see in the roadmap here, IHI, why the boiler goes like this. That is because the IHI applied our ammonia technology to reduce the coal consumption in the boiler firing and try to maximize the new boiler or the midterm boiler can be used for until the end of the lifespan. For example, if the boiler was operated in 2020, for example, then the lifespan would be 640 years. Then that would be ended by 2060. Yeah, so then if they can apply the ammonia as a fuel, then the boiler would do not need to be demolished or be suspended. Yeah, so then in the future, the boiler, coal-fired boiler, will gradually to be reduced, and in the future, the GT and the engine will dominate the market. And then this is our press release that which we conducted 20% in 2024 April 10th and complete in June. Then here is the bird view of the project, and we conducted the boiler ammonia firing in Unit 4, and here is the demonstration facility with the pipeline, and you can see here are the testing facilities. And this is our press release, which we signed a MOU with GE, and then we already our test facility has been established in our IOE works in Hyogo. And about the Taiwan market, we have signed with the MOU for the FS with the TPC on the 2024 February 29th, and we are making the study for the ammonia firing above at least 5% by 2030 with TPC, and now everything is still under discussion. And we also signed the MOU with the Taiwan Fertilizer. They are the biggest ammonia supplier in Taiwan, and we signed the MOU to jointly to develop about the ammonia business in Taiwan market. Then this is about the engine. Then this is the IHI Alchemist signed the term sheet to supply the green ammonia India to Japan. And this is one of our member. And also this one is IHI did the Indonesian partner to complete the Southeast first ammonia combustion trail in Indonesia. And I would like to highlight in this project that the boiler that is not IHS boiler. And in this boiler, non-IHS boiler, but we can do the ammonia co-firing. So I would like to highlight that in IHI we are not just capable for the IHI OEM's boiler, but also other OEM's boiler we also can make it. Okay, this is my presentation of today, and thank you very much.
Thank you for sharing, and hope that we can see more news like what you just shared in Taiwan, to have more maybe imports of ammonia from India to Taiwan, and also co-combustion testing in Taiwan with the Taipower. We're looking forward to it. So now, since our last speaker of today, the Dr. Mark Lin, he will be joining us no later than, he will be joining us maybe until until 45 or 6 minutes later. So I think if there's any questions that you might have upon the policy or the entire industrial environment for us, feel free to ask. You can type your question in the chatting room or the dialogue. Okay, thank you. I think we have one of you.
Thank you everyone for joining, and so far it has been great, presentations from all the presenters. So, Mr. Akshay, I would request you to introduce yourself to our audience.
Yes, hello everyone. Nice to meet all of you. Exciting to hear about a lot of progress on the front of hydrogen production, ammonia production, and its use cases. Green Fuel Energy Solutions is a 20-year-old company. We started by doing products for vehicles that run on natural gas. And now we do LNG, as well as we've done 35 trucks that run on hydrogen. So we are primarily in the automotive sector, where we are utilizing newer technologies to rapidly decarbonize fleets and trucking. We also have a business for lithium-ion battery packs. I myself have, of course, been to Taiwan at least 8-9 times. Done a lot of work with companies and people there on battery projects. As you know, it is the hub of a lot of electronics. So exciting to be here. Happy to share my views on hydrogen, especially in transport and long-haul heavy-duty trucking.
Thank you, Mr. Akshay. I have a question for you, as in, since you're in the transportation field, and our country especially is a lot dependent on the imports of crude oil. So we pay huge bills. I come from Bharat Petroleum, which is one of the largest importers of crude oil. So, the fiscal deficit issue and all those things. So how do you see hydrogen in future reducing this issue and, solving this problem of importing the crude?
Yeah. So thank you so much for this question. I think, there are a lot of debates around hydrogen, its efficiencies, production, and use case of electrification versus hydrogen. But I think for us, the main issue is threefold, like you said. One is energy and energy security, right? The second is decarbonization, and the third is urban pollution itself. Right. And I think for us on the urban pollution and fossil fuel side, it's a very interesting concept of using hydrogen, because about 3% of our total vehicles on Indian roads are trucks, but they emit 50% of the pollution, road transport pollution, right? Particularly particulate matter and things like that. When we look at long haul transport, which means anything over 500 kilometers, and we use trucks as our main source of transporting goods, they're primarily running on diesel today. And they need power for gradient, for payload, etc. Over there, I believe hydrogen has an edge over electrification also, because of payload requirements. And then chargers, etc. on highways, it might not be very practical. Also, hydrogen filling times are lower, much lower than charging a truck. India is uniquely positioned, Abhinav, because we have some of the lowest prices on solar power today, right? Especially around the clock. And if we are able to utilize that in actually producing hydrogen, and we've done a simulation that if we get hydrogen at 150 to 200 rupees at a pump level, right? And there are some, changes or price down on the hydrogen storage technology, because we use hydrogen stored at 350 bar on the automotive side, and there are a lot of composite tank manufacturers coming into India. And I believe Reliance has also committed to putting up a carbon fiber plant. So if these 2-3 things come together, which is lower cost of solar power, increased efficiency. So we've done a simulation again, and we believe that if we are able to do 30 to 35 units of power for production of hydrogen, which today is approximately 55 units, right? We would be uniquely positioned to really use hydrogen to decarbonize the largest part, which is heavy urban transport, where it makes maximum sense to use hydrogen. Yeah. And that will add huge amounts to decarbonization, pollution, and most importantly, our own energy security, because we cut down our import bills by quite a few billions of dollars. I have some numbers we can share. Yeah, sure. Go ahead.
Thanks, Akshay. Thanks for that. Now, when we are talking about transportation, the second thing comes that, the EVs,
Yeah.
which are there. So do you think that EVs are complementary solutions, or do you see overlap in certain segments within transportation segment when we're talking about hydrogen and EVs?
Yeah.
So how do you see that?
So I think, let's be very clear that India is going to be a multi-fuel pathway. All right. We have different segments of vehicles, high volumes, and therefore I don't think one particular technology is going to rule the roost. I think EVs make maximum sense on the two-wheeler and three-wheeler side. But beyond that, you start getting into different kind of economics and issues of charging, of weight, etc. So, I think it's going to be complementary. It's definitely not going to be, predatory in nature. Ultimately, it'll boil down to maximum impact for the government and the users, which is in India, and B, for the consumers, right? Every logistic costs in India are highly competitive, right? And that competition only keeps increasing. What is interesting from an India perspective is that 65% of our cost of fleet is fuel cost. You take that to Europe, and suddenly that flips because 65% is the cost of a drive. Yeah. So, over here, reducing fuel costs while decarbonizing is our real challenge. And I think that's where hydrogen is an extremely sweet spot, but there is work to be done. We need to bring down the cost of storage technology for the vehicle. The fuel cell cost itself has to come down. And I know the Chinese have already reached $1,000 a kilowatt hour. And, once we have scale, I'm sure that can be brought down. And when we do that from a trucking perspective, it makes great sense because the payback is faster. I think a lot of people would know this, and there have been experiments done already, where a liter of diesel on a typical 6-cylinder truck would give about 3.5 kilometers per liter, whereas hydrogen can even give up to 12. So it's an average of 3 times. So the payback becomes pretty good. And that's why I said, if we are between 150 rupees to 200 rupees a kg, and a truck cost even at 80 lakhs or a crore, the economics start making sense.
Thank you. Thank you, Akshay. I will hand over to Sebastian now
Yes.
to, discuss with Mr. Akshay for further.
And but I think before we go through the more thorough discussion, I can do a quick response to what you just discussed. So one is using hydrogen or ammonia as a low carbon fuel, and the other thing is its utilization in transportation areas. Is that correct? So
Yeah.
For Taiwan's perspective, well, it's actually using hydrogen itself. It's more like a solution for reducing carbon emission. And we are able to talk about its utilization in different scenario. But the key points in Taiwan is the electricity carbon emission coefficient. So far, our carbon emission coefficients in the 2024 is about 0.44 to 74 kilogram per kilogram CO2 equivalent per kilowatt hour. So that's still a relatively high emission for these ICT firms. So one big mission for the Taiwanese government is to use hydrogen or ammonia to reduce the entire carbon emission coefficient. So that's the reason why the Taipower and the national flagship project, they have both put a large focus on using hydrogen or using ammonia in the fire power plants. So that's more like a big deal in Taiwan. So that's the big demand that's in Taiwan market. That's for the alternative fuel parts. As for the transportation utilization, I have to say, if you make a comparison for Taiwan with EU, with US, well, maybe not nowadays US, maybe California specifically, we take a look at the density of their HRS. We can't compare with them. We only have the first HRS. But the key, I believe, well, maybe India, you're very gifted with renewables, so you're also very gifted with renewable green hydrogen or green ammonia. But in Taiwan, if you take a look at the energy import brochure, which is published by the Energy Administration, I think more than 90% of our energy are imported. So in that case, even if we move the eras up until the electricity era or the era of using more and more hydrogen or ammonia, we would definitely still be a net energy importing country. So in that case, we're not considering the price, considering either it's local produced or it's imported from a foreign country. I have to say that, well, as an association, hydrogen association, as a partnership, we're definitely try our best to promote all types of utilization of hydrogen, of ammonia. But however, if we are to face the facts, there's a cost. So it's hard to convince the public to take FCEV passenger car instead of diesel cars or let's say hybrid would be good enough for now, considering the price of the fuel and the price of the car itself. So that's the reason why there's only one HRS, and the Taiwanese government's now still focusing on the mass transportation like the FCEV bus. Because for that part, the public transportation is the most efficient way if you're seeking to reduce the emission. And also these public transportation service provider, they're easier to acquire these. We can either say it's policy support or subsidy fundings, because comparing with some private person like me or you and like everyone. So, okay, just some short response to the topic here.
Yeah, so thank you, Sebastian, for that information. Yeah, as I mentioned to you, I think every country will have to look at clean energy and energy security together, right? Especially in today's geopolitical world, I think self-sufficiency along with decarbonization are both important. Now, coming to the Indian perspective, and I think maybe that's why we are uniquely positioned is because of the renewables, right? And the price of solar power per unit in India, thanks to a lot of government support, is really low, right? I mean, it's almost 3 rupees. I mean, I don't know how much in Taiwan dollars, but 3 rupees a unit, a kilowatt hour, right? So to answer the fuel question, if you want to go from well to wheel, which is what you were talking about, right? If you're going to produce from coal and then produce hydrogen, it makes no sense. So eventually it is going to have to be green hydrogen, right?
Yes.
So I think that's where India is uniquely positioned because there's two pathways to it actually. One is solar power, but the other, which a lot of us seem to forget, is compressed biogas can be used to produce hydrogen, and India has the potential to produce 62 million metric tons and solve its problem with waste, and that is a net, negative carbon. If you look at the entire carbon value chain of producing biogas. Uh, Now, we were talking about use. I think the car and personal car use is far away. And as I mentioned in my presentation earlier or in my discussion, 2 to 3% of the vehicles are the heavy vehicles. However, on the other side, that is what we call as 50% of the pollution emissions in India. And that's why that is where the sweet spot is to look at use of hydrogen and maybe LNG as fuel. Now, I want to put a caveat here. We are talking fuel cell vehicles, which is still far away. But there is an interim solution which India is experimenting a lot on. And with the 35 trucks that we have done, is based on combustion engines and not fuel cells, right? So the combustion engine still has the problem of producing NOx. Okay, so it's not zero emission. Having said that, it is a pathway to reaching zero emission from a cost perspective, from an infrastructure perspective, all that, you know? So, and I think the use case really is in trucks and not so much in buses at the moment. The fuel cells, as they become slightly cheaper, and as I mentioned, the target cost of a vehicle has to be, a truck has to be about 1 crore of rupees with hydrogen, which is difficult to do at this point. But if we can do that in certain ways, because it will avoid a lot of other products on the vehicle, and bring hydrogen costs between 150 to 200, we are going. So I was talking to this gentleman that in Ladakh, India has been experimenting in the higher altitudes with fuel cell buses running on hydrogen, and they are giving 18 kilometers per kg, whereas on diesel they were giving only 3 to 4 kilometers per liter, right? So you're talking almost 4 times, right? Now, and I think that is a very interesting prospect. But I think the pathway is like this. Green hydrogen produced on solar, when it reaches a certain target of 150 to 200, that will be net negative carbon. And then we will start with IC engine on hydrogen in trucks. I don't see that happening on vehicles, personal passenger cars at the moment, and we need to attack the elephant in the room, which is the long haul transport, right? And then move towards fuel cells. I think that's the most practical pathway to make hydrogen mass produced, hydrogen mass used, in our context in India.
Okay.
Yeah, so I think Taiwan and India have some different demographics, and fuel cell buses will right now be only experimentation just to come out with the right parameters. And of course, the costs will be much, much higher. So I think a practical reality is to look at hydrogen as a combustion engine in the beginning.
Yeah. Actually, I think throughout my slide, I just shared a few hydrogen. Well, actually, one domestic development of fuel cell bus, and that's have to admit that so far in the foreseeable future, that's the first FCV bus will actually be the product of Toyota. Their Gold City, I believe everyone knows about it. But still, not just the company that Hardin Valley they're developing now, but also our next speaker today, the Blade Hydrogen Green Technology. They're also working on developing their own bus.
This is my company. Some information about our revenue and capital. Our main product is we make the fuel cell system is more than 24 years, and we have also developing anion electrolytes and metal plastic. Please next page. Okay. When we speak from spin off from the national level, our first things we need to apply our product for the worldwide certification for the safety. So the one is the TV Ryan is come from the Germany, and we have a 30 kilowatt and 150 kilowatt, and the other one because our fuel cell devices also put in the semiconductor line, assembly line. So we also need to apply to the SEMI S2 approvable. Next page, please. Next page. Okay. The first challenge is in the Taiwan, where is the cheaper hydrogen. You know, if the hydrogen will that will be one of the energy, so the cost and the stability supply is most important. If we're using the pure hydrogen in the Taiwan, that is really so expensive, so it almost impossible to make the commercialize, except some backup power. So our first things we need to using Taiwan have a huge amount industry byproduct hydrogen. That means Taiwan have a lot of petroleum chemical company, and Taiwan have a lot of very famous semiconductor company. When they doing their manufacturing process, they also generate a lot of wasted hydrogen. The hydrogen is that means not pure hydrogen. Is a lot composed a lot of different composition. So we're using this byproduct hydrogen and to make the generate the power and then reduce the CO2 emission. Please next page. So in the previous time, our pain point is if we how to deal with this byproduct with the hydrogen. We needed to using the scrubber to burn it, and so we also needed to natural gas. So that will be increasing our ESG problem. So our solution is please next page. We're using the fuel cell. Because we have many years dedicated for the fuel cell, so we are well known to how to control the fuel cell, the technology. Unlike other fuel cell company, they also only need the pure hydrogen. Our fuel cell system is quite different. We allowed some syngas. Syngas means we don't need it so pure, like 99.9% very high percentage concentration of pure hydrogen. No, we don't need that. Our hydrogen concentration only allowed 50% is enough. So we're using this to generate electricity power. Please next page. This is what we do, and we make our metal plate stack, and we make the BOP. BOP that means the peripheral devices like the air pump, like the hydrogen pump, and we also make the power electronics. Next page. So our key technology, we a lot of innovation pattern, more focus on how to deal with the syngas hydrogen. Please, next page. This is our stack automatic assembly line. We're using the AI to accumulate some lot of assembly parameter. Then we put the cloud. The cloud will be to analysis and to more intelligence. Let our manufacturing yield rate is more higher. It is no need. It is all the robots to operate. Please, next page. This page we're showing our metal plate stack. The metal plate stack is more criticized by the life. So our life now can up to the industry standard more than 2,500 hours, and our almost except the some MEA and almost the other component in the stack we can all made in the Taiwan. Please, next page. We're using this syngas as the input. We also get the green power certification in Taiwan. That means like the solar, like the PV, like the wind power, and we are also be provable by the green powers and can generate electricity. This is our first certification in Taiwan. We can selling the green power. Please, next page. This is an example. We put our machines, our hybrid input fuel cell machines in the petroleum chemical company. You can see the lot of picture, and you can see this petroleum company, their tail gas, the composition is so complicated. They have a hydrogen, they have a nitrogen, oxygen, methane, CO2, and even the water. So the different, and we can directly input our fuel cell machine, and they can for the long time to generate the power. Please, next page. This is another application we put in the Taiwan more famous semiconductor company, the TSMC. You know the TSMC, when they EUV manufacturing, they are also generate a lot of huge amount syngas tail gas. Their hydrogen concentration only about 60% or the 50%. But we can directly input, no need to PSA, other very expensive devices. Please, next page. This is 2 years ago, we installed 500 kilowatt in the Taiwan. This is another petroleum company. Their company, their hydrogen tail gas concentration is only 90%. So they have other 10% is CO, CO2, and the nitrogen and the oxygen. We set up the 500 kilowatt, and this is a Taiwan first hybrid input the fuel cell company machine, and we had still generated the power. Except the syngas input the fuel cell, we're also developing the ammonia. This is we set a ammonia 5 kilowatt cracker. Cracker means we just input liquid ammonia, and they are divided to 75% hydrogen and 25% nitrogen. In the other company, when you need to delete 25% nitrogen, they can generate. But for our system, we don't need to. We can directly input this 75% and the 25% input and let generate the power. For the pure hydrogen, we have also developing more than several years. This is our fuel cell bus 12 meter, and their chassis, and we have also logistics the vehicle is a 30 kilowatt. Please, next page. We are also developing boat. Taiwan is the ocean company, and we are surrounded by the sea. So we have a lot of island, isolated islands. So we needed to lot of boat for the long ranges. The distance is cannot meet by the lithium battery. So we're using the fuel cell and with the tank. We also different. We also develop a different kind of vehicle, like the you can see the fuel cell forklift. Please, next page, and UAV, and the UAV is they can running at least 2.5 hours, and with the 350 bar tank. Okay. And we are also developing motorcycle in the Taiwan. Taiwan have a lot of motorcycle. Please, next page. Because we have also developing the annual electrolytes. This is our electrolyte stack. Now we have two kind of product. One is we can generate 0.5 qubit per hour, and 2 qubit per hours. And this is our BOP. Okay, please, next page. This is my last page. Because we also developing the vehicle, so we also developing the refueling gas station. We are put all the material like the compressor, like the dispenser, and like the refrigerator is a pre-cooler, put one container. So it is movable, 20 feet container movable. And so this is our each component. And for the container-based stationary, it's more compact and a small size. And we are also developing the cost down. We are using the hydraulic compressor replace the traditional diaphragm, the compressor, to reduce the price at least one half. And we also storage tank. Okay. This is my whole presentation. Thank you. You pay attention.
Thank you, Sebastian, and thank you everyone for joining today. And I think I appreciate we appreciate the sessions and was really fruitful, Sebastian. Thank you so much. Thank you, everyone.
Okay, thank you.
Thank you. Thanks.
See you next time. Bye.